All right, we're going to talk about slope. Okay, slope is something that you see all the time. For example, a ski slope has a rise and a run, how steep it is, or how gradual the ski slope is, or a hill. Slope is very important. Seeing how like landslides and so forth, places that are possible places that could have landslides, or knowing the terrain of an area, maybe building, if you're a city planner, how to put roads in, where to build houses at. Those are all very important. One thing is common terminology amongst people who like do roofing and stuff is like a 412. A 412 means that the roof rises 4 inches for every 12 feet it goes out. And so that's what we call a standard roof. And I'll put a picture of that standard roof. Now that does have some effect. If it's not 412, it might be a 312. That's not very good. You don't want a very gradual roof. You definitely don't want a flat roof. There are flat roofs, but they have to have some slope to them. Even when you're making, for example, a driveway, or um, you want to have some slope to that so that water can run off. Even if you don't think it's that big of a deal, it is a big deal. You don't want the slope of the ground to go towards your house. Why is that important? Well, because you don't want rain going when a whole bunch of rain comes. You don't want that rainwater going towards your house down slope and into maybe your basement. So those types of things are important to look for. So slope has some real impact, not just math wise, but in the real world. So a standard roof, like I said, is 412. So it rises every 4 inches for every 12 it runs. 12 inches it runs. So 4 inches for every foot. It has to be at least that. That's usually standard. That's usually what permitted. Now it can be steeper than that. Some roofs you've probably seen houses have very steep roofs. Right, those obviously are hard to work on, but they last longer because the water doesn't have the ability to sit on the roof. So those types of things come to play. Now, if we're looking at a graph, so an XY, we have a Y and an X axis. We have different types of slope involved here. Now, this is a linear function. It's part of a linear function. It's part of this y equals mx plus b. And we're going to talk about that here in a second. This m is the slope. Now, in seventh grade, we talk about that. We talk about this, a proportional relationship, y equals kx. It's actually the exact same thing, except it has a k here instead of m. And so k is actually the slope, and there's no plus b because the b is the y-intercept, so where it crosses on the y-axis. So this k is actually the slope. It's the constant. Okay, the slope is always constant with the graphs, and so there's no b here because it's actually plus 0. Because this is a proportional relationship, it always goes through 0, the origin. And so this is the proportional relationship, and it's just written like that, and that's what we have in 7th grade. 8th grade is this with the y-intercept. So the slope is actually the k, except it's not called a proportional relationship, it's just a linear function. So you have different types of slopes. We categorize them by which direction they go. So if they go this direction, that is a positive slope. So that's a positive slope. Okay. If we have one that's going down, this is what we call a negative slope. If we have a flat one, so here's our x, here's our y-axis. If we have a flat line like this is called a 0 slope. Okay, it's just y equals, right? Y equals whatever the y-intercept is. Okay, um, and this one is called one that goes straight up and down. It's called undefined. The reason why is because it's straight up and down. You can't have a slope that is straight up and down. There's no slope to it. Not no slope to it. It's undefined. You just can't give a slope for it. If it's flat, it has no slope, so it has 0 slope. If it's going from left to right, that would be a positive slope because, well, it's going left to right. Think about it as like a company's on a graph. If it was their profits, and if you can walk up it, it's going up, and so it's positive. If you're walking down it, that would be negative. All right, so that's a negative slope. Undefined is straight up and down. Now, this is usually what happens here. This is actually this equation: x equals any number. Okay, so like x equals 5 here. So this any coordinate point along here, x is always 5, no matter what the coordinate point is. So if we have like, for example, 5, 6 here, we have 5, maybe 1 here, and then we have 5, -1. Okay, the x axis, the x coordinate point's always 5, and it's x equals 5. So that would be that. For a zero slope, it's always like y equals 5. So the y value on the coordinate is always 5. So any point along here, the y value is always 5. So this is, maybe this is -4, 5. This one down here is -2, 5. This one is maybe +2, 5. And no matter where you go on this line, that coordinate point, the y value is always 5. And that's just y equals 5. There's no slope to it. There's no mx. Okay, so there's no mx there because it's just the y-intercept, which is the b, is just y equals 5 because it crosses right here at the 5 on the y-axis. So you have positive slope, you have negative slope. Now, how do we find slope? There's a couple different ways we can find slope. The main way they talk about is we can look at on a table, we can look at it on a graph. Okay, so slope is what rise, you'll hear this a lot, over run. Now, some people do this by, with coordinate points, they do y2 minus y1 or x2 minus x1 on the bottom here because the run is left to right. That's the x-axis. Rise is up and down. That's the y-axis. So that's why we're looking at the y-coordinate point and the x-coordinate point. Now, I like to write this as delta y over delta x. All right. Delta, this means change in. So whatever the change in the y, went from this one to this one, how much did it change? How much changed from the x? So we get that. And so let's say on a coordinate point, we have 2, 5, and we have 4, 9. So we want to see how much it changed from that. Now, if you're doing the y2 minus y1, you just do the first point is your x1, y1, x2, y2. And so that would be your coordinate points. You would just plug them in, y2 minus y1, so 9 minus 5, 4 minus 2, and you can do that. Or you could just say, okay, from 2 to 4, I've changed 2 spots, and 5 to 9, I changed 4 spots. Either way works, okay? So it's not a big deal about which way you go, all right? It's changing the y's and changing the x's. If we're looking at on this on the coordinate point, so we're looking at 2 coordinate points here. Let's say this is 2, 5 right here, and then we have 4, 9. We would just go the rise. We count how many up, and then how many to the right. Okay, how much did we go up? And basically kind of makes a little triangle here. We can see there's a little triangle basically made out of it. And that's actually kind of important. It kind of gives us to the distance formula, but we're not going to get in there today. We're just talking about rise. So the rise to the run from point to point. Now you see this goes up and to the right. Now, if you're looking at this on a coordinate on a graph, what did we talk about when we talked about vertical and horizontal number lines in Unit 1? Going up is positive. To the right is positive, okay? So up and to the right, okay, it's positive. Up, right, positive. And we look here, we put our change in here. Y2, 9 minus 5 is 4. 4 minus 2 is 2. So our slope is 2 over 1, or 2, okay? Now, same with, you can do the change in the y's. We can plug those in there. Or we could see it on a graph and go up to the right one, and we do in that same spot to the right one. Now, if you go in reverse, so this is where you have to be careful. If you're going to reverse, they're both negatives. And this is why a proof of what we talked about in Unit 1, that a negative divided by negative is a positive. Because if we go here, if we go backwards, if we go down and to the left, that's a negative, right? We go down 4 and to the left 2. Hey, we're still on the same line. We're still on the same path. And that's why a negative divided by negative is a positive. Okay? So negative divided by positive is going to be the same slope as this. It's still the same slope. So if I go down 2, down 4 and to the left 2, I'm still on that same path. Okay? I'm still on that same slope. Okay? That has not changed whatsoever. And so that slope and rise and run, that's what our slope is. It can be positive, it can be negative. Okay. So let's do a couple more. All right. So let's say we have -5, 2, and we have -5, 4. Okay, so our x's are the same here. And so we do our rise or run. So we're near y's first. From 2 to 4, we changed how much? 2. Now remember, you can do the x1, y1, x2, y2. Subtract those. Okay. Just remember your negatives. Okay. Because if you do the x1, y1, x2, y2, 4 minus 2 is 2. -5 minus -5 is 0. And so 2 divided by 0. So if we do change in 2 to 4, 2, changing this was 0. Now, can you divide by 0? No, it's undefined. This is undefined. So if we look at it on the graph, -5, 4, -5, 2, oh, hey, there's 2 points. It's a vertical number line. It's a vertical line. So it is a not no solution, but a undefined answer. We don't know what the slope is. It's impossible because it's straight up and down. Okay, it's a vertical line. Do another one. So let's say we have 10, 6, and then we have 6, 10. Okay, so we have 10, 6, and 6, 10. Now, this is weird because it's like, okay, we're going backwards here, and that's fine. But if we x1, y1, x2, y2, 10 minus 6 is 4. 6 minus 10 is -4. Or 1 over -1, or just -1 over 1. Now remember, I can move this negative to the top if I want to. It's on the bottom. I can move it. This is a negative slope. So if we looked at it on a graph, we have 6, 10. All right. We have 6, 10. That's the 6, 10 one. And then we have a 10, 6. Let's say that's my 6. It goes down over time. Okay. So that is a negative slope. It goes down. There we go. All right. So, and it doesn't matter what order you have this. It doesn't have to be perfect order. You know, this 610 should have been here first. Just my x1, y1. That doesn't matter. Okay. Whatever the change is. Change in these two was -4. Change in these two is a +4. The rise. Okay. The y's. So we get this, and that's a negative slope. So we have -1 over 1 or 1 over -1 because you can go either way you want to on the graph. My rise, if I go up 1 to the left 1, I'm still on the graph. If I go down 1, because this is -1, to the right 1, I'm still on the graph. Okay. I'm still on that line. No matter what I do on that slope, I will always end up on the line for that slope. Okay. For that slope, it's always on the line. So one more. So let's say we have 2, 8, and we have 4, 8. So you can do x1, y1, x2, y2, does not matter. I'm gonna do my change. 2 to 4 is a +2. 8 to 8. Oh, sorry. See, I just messed up. My x's are my runs, right? So 2 to 4 was 2. That's be in the bottom. 8 to 8 is my y's. That's 0. Okay. So this one, 0 can be divided up all you want. It's just 0. Okay. 0 slope. So if I look at it on the graph, I have 2, 8. I have 4, 8. It's a horizontal graph. Okay. So that would be a horizontal graph. it has zero slope whatsoever.
Now, I want to talk about trying to find out what our x and y's are and finding out what the y-intercept is.
This is a pretty long video. It has a lot of notes in it because Apex kind of shoved everything together.
Um, so we can look at a graph. If you see on a graph, all right, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We're just going to do very simple stuff. All right. If you're given 2 points, let's say 3, 4. All right. Whatever. But and then we have 0, 2. So we have 3, 4 here. We have 0, 2 here. They'll give you the y-intercept. Okay. So this y-intercept, if we look at y equals mx plus b, this is the y-intercept. This is the slope. Right? Now we know this slope should be positive because it goes left to right. Y and x are just coordinate points. That's all they are. You can plug in whatever coordinate points you want as long as it's on that line. We're not going to plug any points in. We're going to find out what the equation is here. So changing the x's is 3, put that in the bottom. Changing the y's is 2. So our slope is 2 over 3, and it's positive. There's our slope. Now, the y-intercept is very easy to find. Where is the line across the y-axis? Right here at 2. Okay? So our equation here is positive 2. So our equation is y equals 2/3 x plus 2. So if it's in a graph, it's very easy to find. Very easy to find. Okay? So that's not an issue. It's very easy to find that way. However, what if they don't give you a graph? Okay, what if they give you the 2 coordinate points? Okay, not a big deal. We can find that out. So let's say on a graph, you should have the y-intercept. Put that right in there. That's pretty easy. I generally use the y-intercept on a graph as one of my points, and then I pick another point on it to be my other point to find the slope. That's generally what we do. So once again, y equals mx plus b. Y-intercept, slope. Now, if I'm given 2 points, let's say I have, let's say 4, 10, and let's say I have 6, 2. Okay. So we're going down. We're going to find the slope first. So we know we want to find y equals mx plus b. We have y, we have x. These are just coordinate points. M is slope. B is our y-intercept. So we're going to find the slope first. So change in our, so once again, you can do x, y, x1, y1, x2, y2, whatever. It doesn't matter. Whatever makes sense for you. Changing the x's is 2 for the x's. That goes on bottom. Changing the y's is 8. That was -8 because it went down. Okay. So, or -4 over 1. Okay. And remember, I can still write it as -4. All right. So, or -4. So I'm going to plug this in up here. So now this becomes y equals -4x plus b. Now, I need to find out what my b is. I can graph this if I want to. I can put this in a graph and then make my line, or I can find this mathematically and find exactly what the y-intercept is. And here's how we do that. We're going to plug in one of our coordinate points that we know is on the line. These 2 points we know is on this line because they give us the slope. So you can only solve for one variable at a time. Just like in science class, you can only solve for one variable in an experiment. You can only solve for one variable at a time in a mathematical equation as well. So we're going to plug in one of these points in here. All right. So I'm going to plug in 4 for my x, 10 for my y. So now this becomes 10, and this is where evaluating expressions in our second unit, that's where this comes in. So -4 times 4 plus b. Well, -4 times 4 is -16 equals 10 plus rb. Solve by adding 16. 26 is our y-intercept. So now we can plug this and put 26 there. Okay. So y equals negative 4x plus 26 is our y-intercept. And there is our equation. Now, why is this important? Well, now we know the equation. Now we can put anything we want in for an x. We can put input in. So if this is something as a data collection that you're trying to make predictions, if we only have two known data points, right? If we only have two known data points, you can now make predictions about something. And that is huge, which is what companies do. They make predictions about you and me based off the data they receive from us from just surfing the internet. All the data, surfing the internet, going to this web page, looking at this product, that's all numbers. And they make predictions about what you want to see in that algorithm on YouTube. They have everything numerized, like basically numerical. Okay, and they're able to, based off those numbers, figure out what you should be watching next. What are you interested in next? It's making those predictions to keep you watching, so they can sell advertisements and get money. Okay, so that's important. Now, this is just scratching the surface, very basic, but that's what they're doing. And so let's plug in the other point just to make sure. You don't have to do this, but I just want to make sure you understand. If I plug in the other point, well, if I plug in the other point, 6 for x, 2 for y, 2 here, all right? I plug 2 in for the y equals negative 4 times 6, right? Plus b, because we don't know what the b is yet. That we know it's 26, but that's negative 24. Negative 4 times 6 is negative 24 plus b. Now I add my 24 to solve. Negative 26 equals b. Hey, we get the exact same thing. So because we know those points are on the line, we can plug one of those in and solve for our b. Okay. Now I know this is a very long video and it has a lot of stuff. Remember, pause it, rewatch it, stuff like that. Ask me questions at school if you need to. Look through your notes on Apex. Please do that. Like I said, a lot of times we do a lot of this stuff in Flex trying to get everything in for the year. But you can pause it, you can watch it at your own speed if you want to, and then you can ask me questions at school. All right. Have a good day, guys. Bye.